Cool. All right, children, let's begin. Yes, children. Yes. Okay, so you have asked me to please do another model walkthrough of the redox question. What you guys have as potential combinations, I like to classify them as you have your easy redox equations, which are just the ions. You also have the harder redox equations, which require the balancing of the water and the hydrogen and the oxygen sort of thing. So I can really choose any two things to put together. My question to you guys is, do you want me to do two hard ones? So you can see two examples of complex balancing of the equation and how the water would cancel out and things. Yes, I see nods. All right, cool. I'll do that. So I'm just pulling things off the sheet and deciding what I want to do. And creating a question out of thin air. And you guys can do this all the time because we have this resource sheet, and so long as you grab one oxidant and run one reductant, you can write the reaction. So I'm going to choose permanganate, and we'll call it potassium permanganate because that's usually how you find permanganate. And that one is our nice purple color. The other thing I want to grab is going to be sodium sulfide. So this guy's a little bit different because it's SO3 instead of SO4. SO4 is sulfate. This is sulfite. Are we good with that so far? So we're mixing these two solutions together. And what I'll do is I'll tell you the observations and then we'll record them down. So potassium permanganate is a purple solution. I can see that from the two ions that I have there. Potassium isn't even on this list, but it is a colorless ion, and then the permanganate down here is purple, so I know that's a purple solution. The sodium, again, in a lot of cases, some things are not on the list. If they're not on the list, it's because it's definitely the spectator. So it's not involved in that redox reaction. So sodium, I can't see on the list. I can rule out that's already a spectator. And if I look for sulfide, which is that SO3 2-, it is colorless. So what I'm doing is I'm mixing a purple solution into a colorless solution. So let's write that down first. Mixing a purple solution. Specifically, that's caused by my permanganate into a colorless solution, which is that NaSO4, because the whole thing is colorless. Are we good so far? All right. I will then give you the statement. When these two solutions are mixed together, the solutions turn from purple to colorless. So that then helps give me a hint that something's happened chemically and that I have some sort of new ion there. So we can write after mixing, solution goes colorless. And the reason why it's now gone colorless is if I look at these chemical reactions and I look for permanganate, it's going to the manganese ion, and I find that guy on my sheet here, and that is colorless. So that makes sense to why the purple color is now gone. So I'm going to justify that because my purple is now gone. Are we good with that so far? So that's my setup for my observations. Cool. All right, next thing then, we need to figure out which is the oxidant and which is the reductant. Before I even do that, let's just drop down our vocabulary words to help us get to that achieved level. So since I'm dealing with an oxidant, remember it is given that name for what it's doing to the other half of the equation. So it's oxidizing the other half, meaning that this guy is getting reduced. So this is your reduction reaction. And then we still need to figure out what the oxidant is. On the flip side over here, reductant, it's reducing the other component. So it is getting oxidized. So this is the oxidation reaction. Again, we don't know the reactant yet. Are we good so far? Right, other things to drop down is our vocabulary. So reduction reaction, we know it gains electrons, or we don't know how many electrons. And we also know that the oxidation number is going to decrease. Don't know by how much. Again, remember, just jot down things to help you remember. We know Leo the lion says Gur. So if this is my oxidation reaction, it must lose electrons. So loses electrons, and then the oxidation number is going to go up. Cool. We good so far with that? Yeah. Lots of us, just like I said, this is all for the achieved. The last thing I then need to do for the achieved is I need to figure out my reactants and my products. I need to identify the oxidant and the reductant. So you are going to go to this sheet over here. We are looking for my the permanganate, and we are looking for the sulfite, which is this guy over here. So these are the two ones that I want. Again, I have eliminated potassium and I've eliminated the sodium, because when I look at it, it's not even on the resource sheet. So that tells me already that's the spectator. If it isn't, or sorry, if it is on the resource sheet, think about it logically. So we were talking about yesterday, we had iron 3 and we had the chloride, and I circled, okay, here's iron 3, here's the chloride. These two guys are on opposite sides, so it has to be one of the two, because we can't have it auto-redoxing itself. And I know that the SO2 was the other thing I needed. So since I have, in this case, my reductant, this had to be my oxidant. Does that make sense to how we pull the information? All right. Be careful, because it really kind of snowballs and mucks up the whole answer. All right. So I know from that information that the forward reaction is the reduction reaction, and I see that there's permanganate there. So I'm going to write that the oxidant is MnO4 minus. MnO4 minus, and then the reductant is the SO3 2 minus, SO3 2 minus, and then to identify the products, I use this table here. So that one is going to Mn2 plus, and this one is going to SO4 2 minus. Are you okay with that so far? All right, unfortunately, would be a really mean question to give you guys on the internal or on any assessment, because you have two complex equations you need to balance. So if you don't know how to do complex equations, you're definitely getting an achieved on this. Does that make sense to everybody? So what I will do is I will write things into the, I'll do the half equations, and I'll make some extra notes so you know what you need. Just keep in mind that this here is an OR option. This here is also an OR option. So I just need to see it one way or the other, so that gives you some flexibility in case you make a mistake. So, should I start with oxidation numbers? I think I'll do that, and then it helps you kind of set up for the equations, I think. All right, paper's flying everywhere. All right, so when I'm looking at this, I need to think about oxidation numbers. This here is my manatee's ion, and I need to figure out its oxidation number. I know it's the active component because I can see it's getting to that Mn2+. So I know in this guy, the charge of the ion is the same with the oxidation number, so that's just going to be a simple +2. This one here I need to calculate. So oxygen is always -2 unless it's in peroxide, and that's an exception to the rule, or if it's in the element form and it's 0. So you need to have those memorized. So that's -2 times 4 is -8. This has a -1 charge, so this manatees must only have an oxidation number of +7 in order for the math to work out for that ion to have a -1 charge. Are we okay with that? Yeah? All right, so let's put that in. This oxidation number has decreased by 5, and we have gone from a +7 to +2 from there. Do you have a late slip?
I had a DCAT exam.
Okay. Does that make sense? Yes? No? Good? Yeah. All right. From there, I also know how many electrons it's gained. 5. Cool? All right, next one. All right. SO3 2 minus. So that's negative 2 times 3 is negative 6. It's a negative 2 charge, so this guy is positive 4 right now. This guy over here, negative 2 times 4, negative 8, 2 negative charge, so that's now positive 6. So oxidation number has increased by 2. We are going from positive 4 to positive 6. Note how I'm moving this plus signal. When we're talking about oxidation numbers, the plus and minus go before. When we're talking about charge, it goes after. It's chemistry language. All right, so this has lost 2 electrons. Cool. We go with that? All right. Again, this is an OR option. So you got either the the reduction process right or the oxidation process right. Cool. Let's now start doing the equations. Those are the hard parts. I personally like to line up all my equations in the center with an arrow, so that way it's very easy for me to cancel later. So this is MnO4 minus, and that's Mn2 plus. The second equation I'm working with is SO3 2 minus, and it's going to SO4 2 minus. Cool? Let's do step-by-step process. First thing I'm going to double check is the active component, which is the manganese, is that balanced? 1, 1, good. We don't have to do any multiples. Next thing we have to look for is the oxygen. There's 4 on this side, so I'm putting 4 waters on this side. Now that I've added waters, I need to add hydrogens. So 4 times 2, there are 8 hydrogens there. Last thing I do is add my charge. So I see that this has the charge of positive 2 on this side. This has a charge of positive 7, because that's 8 times 1, negative 1 there. So I would then need to have how many electrons to bring this down to positive 2? 5. And wowee, it matches with what we said over here. That's a fail-safe check. Okay? All right, this one over here, sulfurs, are they balanced? Yes, I can leave them alone. Oxygens, are they balanced? No, I need to add some water. I'm going to add water to this side, because I notice that's a 3, and that's a 4. That will bring this one up to a 4. Add the hydrogen. I have 2 hydrogens now, because I've added those there. All right. Last thing, check the charges. That's negative 2. That is 0, because that's positive 2 and negative 2. I need to bring the higher number down to match, so I need to add 2 electrons to that side. We good? All right. Again, idiot check yourself. Electrons are on the product side for an oxidation reaction. Electrons are on the reactant side for a reduction reaction, because these are gaining it, these are losing it, and these numbers match with the numbers you have stated down here. All right? Everything checks each other. All right. Your last step then is to put it all together. Oh man, we are running out of time. That's okay. So we need to make sure these electron numbers match, and we need to find a common multiple for those electrons. The common multiple is going to be 10, so that means I need to multiply this lower equation by 5 and this upper equation by 2. So 5, 5, 5, 10, 10. Top equation. 10, what did I say? 2, so that's 16. That's going to be 2. That's going to be 2. That's going to be 8. We good? All right. Now let's clean it up and put my equations together. First thing I'm going to cancel out are those electrons to make sure I've done things right. That's an electron. That's 10. These 2 guys are gone. I'll put my final little arrow in there too. All right, next thing I need to do is check to see if I can cancel waters and hydrogens. So if I look, I have 5 waters on this side and I have 8 waters on this side. All 5 of those waters will be removed. And if I do 8 minus 5, I have 3. 10 hydrogen, 16 on this side. I minus all 10. I get that number now to change to 6. Again, idiot check yourself. That is 6 hydrogen ions. That is 3 waters, which have 6 hydrogen atoms. All of the things match. pull through and do my final equation. I am not fussed with what order you copy this down. It just needs to be on the right side of the equation. Otherwise, I cannot help you. That would be an example of a hard one, because you have two equations to balance there. Are we okay with that? All right, there's a few more extra things I want to point out to you guys, in case you make silly mistakes. We good so far? Can I move it? 1 second. Make this bigger. I'm mindful the time's going to run out, and that's okay. Before the bell goes, can you please hand back your mock exams? We've run out of time, but I'll post the answer scheme. Actually, do I need them anymore? I'll let you take them home on Friday, just in case. Oh, wait, no, you guys are doing your test tomorrow. You guys can take home the mock exams. I'll upload the answer key so you guys can use that as a reference point to check your work. Anyway, some things I just want to point out before you all run away. Can you pause? Be careful with dichromate when you're balancing it. This one is a 2, so you're going to need to put a 2 in front of dichromate as your first step. A lot of them don't have that, but dichromate does, so don't forget to balance that and then put in, say, for example, your water molecules. Yeah? The other thing to be careful of, if you have bromide going to bromine gas, be mindful that's a 2 underneath it, so you need to balance and put a 2 in front for those ions. If you have the hydrogen ion going to hydrogen gas, again, the 2 in front. So just watch out for these little gas things, okay? Because a lot of you guys just drop and forget them. And then when you're putting electrons down, you'll be showing 2 electrons. But the justification you'll be talking about, the oxidation number has changed from +1 to 0. It's gained 1 electron.
I'm doing a question similar to the top one. So to balance that, you put 14 micrograms together.
Yep. Like that. And then when you're balancing your charge, what is that? 12, that's 6. So you add 12 electrons? No. Wait, is that right? No. That's too many 6. You balance it with 6 electrons. And then when you're referring to this reaction, remember there's 2 chromiums there. So for 1 chromium, the oxidation number, oh crap, now I gotta figure this out. What is that? 14 minus 2 equals 12, 6. So it's going from +6 to +3, and it's gained 3 electrons.
Yeah. I always just want to remember, gaining electrons is bigger than...
Yes. And that makes sense, because you see how there's 2 chromiums, and you have 6 electrons. So you've doubled it because it's 1 for each chromium. Yeah. Cool. Those are where you guys tend to make really silly mistakes. So, any work you want me to look at, please hand it into my box. I'm sorry I didn't get your stuff marked that you handed in yesterday. Feel free to take some. I know you guys wanted some feedback, so I'll try to mark it and email it to you. Cool. All right. Have a good day. Feel free to take home your mocks now.